Texas Lutheran University.
It's our great pleasure to welcome back one of our alumni, a 2001 grad, Marcie Moehnke, who graduated in 2001 in molecular biology, right? So molecular track, and went on to graduate school at Baylor. So she got her master's and PhD from Baylor. So she is, she's still there. So she's teaching now at Baylor. She's been there for 11 years. I was surprised to hear.
Scary, isn't it?
Old, but that's okay. And she won the teaching award there at Baylor in 2011.
Yes,
so,
11.
So she's, we've been there a little while now, and so she's going to come back and tell us about her life and graduate school and research and all sorts of stuff. So please welcome Marcie.
Thank you. This. Well, I'm very excited to be here and to be back. It's been several years since I've come back for a visit, and the first thing I did is I did go to the bookstore, and that's why my bag is so full. I already made a little donation there to the bookstore. But anyway, I'm so excited to be back, and it's so neat that I'm in this room because I was a student in this room. This room has not changed. I mean, maybe some of the technology has changed, but I think I sat in this area here for a couple of semesters. So. Anyway, well, my primary workload at Baylor is teaching, and so the very little bit of research that I do from time to time is with undergrad students. So I'm not connected extremely well to the graduate program, but I can tell you a little bit about that. So that'll be at the very end today, as I'll talk a little bit about that. But when I was trying to decide what to talk to you guys about, because I don't have a really big research program there, I thought about doing this talk where we talk a little bit of science, a little bit of science history, a little bit of scientific serendipity, and then we move into what kind of lessons can we take away from that? So it's going to be part science, part motivation, so maybe a little different than what you're used to. But anyway, I hope you enjoy life lessons from scientific serendipity. All right, so this is a picture here of Archimedes. You've probably heard of Archimedes before. Archimedes was a Greek mathematician, but he did a lot of other things too. He was a physicist and a biochemist and so forth. And one of the things that he was tasked with by the king is the king commissioned him to figure out if the king's crown was made of pure gold. The king had thought that the goldsmith had cheated him, did not believe that his crown was made of pure gold, and so he wanted Archimedes to figure out if that was the case. Archimedes didn't really know how to do that, so he had to think about it a little bit, and one day as he went to the public baths, that's what they did back then, all right? He went to the public baths and he jumped in, and he noticed that when he went in that the water flowed out. And so in thinking about this, he said, I could use this to determine the volume of the crown because the amount of water that comes out is the amount of water displaced by an irregular object, such as his body, or he could use that for the crown, and from there determine density. So he was so excited about this that he jumped naked from the bathtub and began running through the streets saying, "Eureka, Eureka, I found it." And this is one of our very first documented stories of scientific serendipity. And he did apply this to the crown, and the goldsmith did cheat the king. And I don't know what happened, what came out, but I'm sure it wasn't good for the goldsmith. But anyway, that was one of the first documented stories of scientific serendipity, and there are so many more. I'm going to share a little bit with you today, but it was hard to pick because there's so many really neat stories with this. But before we go into that, I have one of these clickers too. There we go. There we go. Let's talk a little bit about serendipity. These are just a couple of definitions here. The phenomenon of finding valuable or agreeable things not sought for, or the faculty of making fortunate and unexpected discoveries by accident, or my actual favorite here is when accidents have happy endings. I think that's a little bit easier to understand. That's right. And so whenever this, like that. I'm going to put that on there next time. I'm going to put that up there. In thinking, I'm sorry, I'm jumping ahead here. There we go. So where did this word serendipity come from? It was actually coined in 1754 by Horace Walpole after a fairy tale. The fairy tale was called The Three Princes of Serendip. And he said, after reading this, he said, these princes were always making discoveries by accidents or sagacity of things which they were not in quest of. And so because of that, he coined the word there, serendipity. So that's where it came from. So if you're thinking about serendipity, some things that might come to mind. Happy accidents, we talked about that. Luck. See, I was just getting too fancy with my animations there. Chance, fate, coincidence, blessings, right? So think about all these different things when we think about the word serendipity. But when we think about scientific discoveries, a lot of them have been attributed to serendipity. So is that because they just got lucky, right? Good luck. We know that anytime we're dealing with science or research, luck is important, right? That definitely plays a role there for sure. But a comment that Louis Pasteur made that I think really describes scientific serendipity really well is, in the fields of observation, chance favors only the prepared mind. And then to take this in a little bit further, sorry to have a slide with so many words on it, but I thought that this quote does a really good job of describing scientific serendipity. This is by Paul Flory. He says, significant inventions are not mere accidents. The erroneous view that they are is wildly held, and it is one that the scientific and technical community, unfortunately, has done little to dispel. Happenstance usually plays a role, to be sure, but there is much more to invention than the popular notion of a bolt out of the blue. Knowledge in depth and breadth are virtual prerequisites. Unless the mind is thoroughly charged beforehand, or you can think about Louis Pasteur saying a prepared mind, right? The proverbial spark of genius, if it should manifest itself, will probably find nothing to ignite. Right? So when we think about scientific serendipity, there is a little bit of that luck and so forth that goes there, right? Luck, chance, fate, blessings. But I would say that there's some other things in order, the whole reason why we're going to be talking about some of these people today is because they had a charged or a prepared mind, they had the background knowledge, and they were curious. They were curious about figuring out why they didn't get an anticipated result, and they decided to move forward to try to figure out what was going on there, right? And I think that's why they're people that we talk about today. Another way to think about it is they had a plan. They had a plan A. All right, they were moving in one direction with a particular research question, hypothesis, topic, but then all of a sudden they got some results that shifted them in a different direction, and so they had to switch to a plan B. And does that sound familiar? And has anyone ever had, I think we all have had some plan A's turning into plan B's, or several of them. So I want to talk about some of these scientists that had plan A's switch to plan B, and some of these you've probably heard of before. The first one that we're going to talk about here is Fahlberg in 1878. And his original plan was to develop a coal tar derivative. And one day he went home after working in the lab. He was an organic chemist, all right? They do weird things. He did not wash his hands. I'm married to a chemist, so I can say that. I can make fun of chemists. But at home, he tasted something on his fingers. So he clearly did not wash his hands very well, or he was not using gloves, or something was going on there. But he noticed it was really sweet. And he thought that it was connected to some of the compounds that he had been working with in lab. And so he went back to lab, and like a very smart organic chemist, he sampled the compound again to make sure that that was what was actually the sweet taste there. And what he had actually developed was, does this look familiar to you? Sweet and low, all right, the active ingredient in sweet and low, saccharin there. And so, yeah, that's a bit of a change in plans there, right? But had he not had that curiosity, right, we wouldn't have this wonderful artificial sweetener, right?
Which a lot of people attribute to cancer.
Exactly. So look at it however you want, right? Something else along those same lines there. Schlatter in 1965 was a very similar situation. He was actually trying to develop ulcer medication. And I think the story went, he like licked his fingers to pick up a piece of paper or something on his desk. Again, real bright chemists here, right? And notice this really intense, sweet taste from that. And it turns out he developed equal. So once again, a wonderful artificial sweetener there. The next people that we're going to talk about here, this was in 1889, von Mering and Minkowski. They were interested in studying the function of the pancreas in digestion. And so, like we oftentimes do, we're kind of cruel to our model organisms. They actually used dogs. And so they went in and they actually removed the pancreas from the dog to see what would happen, right? And we do that a lot. You know, I do this a lot in lab with fruit flies. I manipulate the poor little fruit flies and then see what happens to them, okay? It doesn't seem like rocket science, but that is how we carry out science sometimes. And so when they did this, however, they noticed that after a few days, where the dog was, around the dog's urine was this crazy swarm of flies, like they never had in the lab. It was actually a lab assistant that noticed this and said, this is unusual. We usually don't get, our dogs that do not have their pancreas removed, we don't have this problem. And they began to look into it, and they hypothesized that maybe the urine had a very high sugar content. In fact, that was what the urine had. And so based on that, they knew that high sugar content in urine was a sign of what? Any ideas? Diabetes, right? And so based on that, even though that wasn't where they were going with this whole thing, right, they actually determined, or they hypothesized here, that there must be something that when the pancreas is intact within the dog that is secreted for the pancreas. They called it a substance. All right, it's our fancy term that scientists use a lot. There is this substance that was secreted there, and that helps to control the sugar levels. Without the pancreas in the dog, it did not have that, and so we saw an increase in sugar levels there in the urine. And so they came to the conclusion that the pancreas is what produces this substance. What's that substance? Insulin, right? That was later. They actually didn't term it insulin. They just called it a substance, and then other people went forward with this and called that insulin. So again,
that was Bandy and Best, 56 of Nobel Prize.
I didn't know that. I'll tell you that, right? I did not know that. So yeah, and again, a plan A to plan B, a little shift there, right? But definitely a happy ending in that case. Anyone heard of Griffith's experiments in here? This is one of those really popular ones, right? I mean, this is one I teach in my freshman biology. I teach in genetics. We come back around and hit on it in molecular genetics. Okay, so you're probably familiar with this, but let's just refresh, all right, go back through it a little bit. So originally, Griffith and colleagues, they were interested in developing a vaccine. Whoa. Jumping all over the place here. They were interested in developing a vaccine for pneumonia, and so they were carrying out some experiments with these mice where they were injecting different types of strains, virulent strains and non-virulent strains, into the mice. And so they carried out a series of experiments where, if you look at part A here, when they injected the virulent strain into the mice died. Part B, when they injected the non-virulent strains into the mice lived. Everything's going nice and neat here, right? They're getting their expected results. Part C here, they said, all right, well, let's take the virulent strain, let's boil it, let's heat kill it, and let's inject that into the mice and see what happens. And so they actually had hypothesized that the mouse would live, and the mouse did. And so, I'm just visualizing them in the lab going, everything is so great, we're getting our anticipated results. That doesn't always happen in science, but they were probably pretty excited at this point. And then part D came along. They decided, let's take that heat-killed virulent, let's boil it, let's mix it with some non-virulent and inject it into the mice. What do you think? What did they predict would happen there? They would predict that the mouse would live because the virulent was heat-killed, right? And then the only thing living they were injecting was the non-virulent, so the mouse should live, right? What happened to the poor little mice? They died. And so I can imagine them going back to the grad students or the undergrad researcher and going, well, you just did it wrong, right? I mean, you need to repeat this. You need to start over again and try this again. You're clearly doing something wrong. We're not getting the anticipated results. But upon doing this over and over and over again, they kept getting the same results. And so they came to this conclusion that there is something, is that substance word again, right? We don't know what to call things, we just call it a substance, all right? There is a substance that is moving from that virulent bacteria, even though that virulent bacteria has been heat killed, all right? But there is something that is moving out of that into the non-virulent and has the capability of transforming it into a virulent strain. And that substance was later determined by Avery and colleagues in several other experiments there to be DNA, but they just called it substance there at the time. And so again, they were hoping to develop this pneumonia vaccine. Some unexpected results came from it, and we're still talking about it today in our textbooks. So interesting how that works. You're probably familiar about the scientific serendipity of Fleming here. I'm going to talk briefly about Fleming, but actually, this is, if you want to read this whole story, the history of this, there are all kinds of crazy scientific serendipitous events that went on here, but I'm just going to talk about two of them. So Fleming, here's the deal. Fleming was a microbiologist, but he was not a very good microbiologist. He had horrible technique. Horrible sterile technique, all right? Dr. Jonas must not have taught microbiology to him because this guy didn't know what was going on, all right? So he was studying some various antibacterial agents was what he was interested in. And so he would plate out different strains of bacteria, examine them, and then one day, I guess he had a cold or something. At least this is how the story goes. We don't know how much of this is more of an over-dramatized tale. I don't know here. But some nasal secretions dripped onto a plate of his. Now that's, even if you haven't had micro, you probably know that that's not sterile technique, right? And instead of throwing the plate away, saying, okay, this is no longer sterile, he just kind of kept it there, right? And he noticed several days later that the place that the nasal secretion had dripped on the plate, no bacteria grew around that. There was that zone of inhibition there, and you can see that in that figure right there. That's not his actual plate, but I wanted a picture there to be able to illustrate that to you. So he said, there's got to be something in my nasal secretions, right, that has some sort of antibacterial properties, and he named it lysozyme, and you've probably heard about that before. A lot of different secretions have that enzyme lysozyme in it, and it has the ability to break down the bacterial cell wall. So he had discovered lysozyme, even though that wasn't really his initial interest. But then he decided to continue on and characterize this lysozyme in a little bit more detail. But once again, he had really bad technique. And so his plates were continually getting contaminated. The story goes, I think, that he plated out some bacteria, left for vacation, and when he came back, he noticed that in several of the plates, they had been contaminated with a mold. And whenever he looked and characterized the type of mold that it was Penicillium, was the actual mold that was growing. But what he noticed, and this is from his paper here, up at the top is the Penicillium colony, right? These are the staphylococcal colonies that he had plated on there. But what do you notice about that? What's going on there? It's away, right? It's away from that mold there, right? And so he concluded that there is something that that mold is secreting that has these antibacterial properties. So what had he discovered there? Penicillin, right? And he named it penicillin after the Penicillium colony there. And so, yeah, discovered penicillin. And so if you want to move forward, there's all kinds of other, whenever they went to mass produce penicillin, there's all kinds of serendipitous events that even occurred along with that. So, you know, if you just want to future reading there, right? You don't have any tests to study for. You can do that this weekend. You don't have anything fun to do. Go read about Fleming. Alfred Hoffman is another one in 1943. He was looking at medically useful derivatives of lysergic acid. And one day he started feeling not so good in his lab. And this is actually from his journal. Last Friday, I had to interrupt my laboratory work in the middle of the afternoon and go home because I was seized with a feeling of great restlessness and mild dizziness. At home, I lay down and sank into a not unpleasant delirium, which was characterized by extremely excited fantasies. In a semi-conscious state with my eyes closed, I felt the daylight to be unpleasantly dazzling. Fantastic visions of extraordinary realness and with an intense kaleidoscopic play of colors assaulted me. After about 2 hours, this condition disappeared. And so he thought, I wonder if this is connected to anything that I've been dealing with in the lab. And so like any good chemist, what did he do? He went back to the lab and consumed it, right? He ate it to see, right? I mean, that's...
And he started Bad Shirt Friday.
Exactly, right? I love this picture. Isn't it great? It reminds me of a shirt you used to wear. Not that, but sorry. So you have to wait till you graduate before you can say things like that, all right? I know. We'll stop there, right? So he went back and consumed some of this because, you know, that sounds like a great way to find out if there was a connection. And he wrote again in his journal after that, he had mild dizziness, restlessness, inability to concentrate, visual disturbance, and uncontrollable laughter. What had he discovered? LSD, right? And then there's even this whole story, old wives' tale, that Crick, as in Watson and Crick, claimed to be on LSD whenever he came up with the three-dimensional DNA model. I don't know if it's true or not, but that's the story. So I'm spreading rumors. I mean, really, when you think about how, you know, coming up with that whole thing, I could see how that could be a drug-induced kind of thing going on there. All right, and now I want to tell you about one of my favorites, and this is another one of those. I'm going to give you a really abbreviated story here, but if you want to go and read about someone cool, it's this lady right here. Rita Levi-Montalcini. Anyone heard of her? You don't hear about her a whole lot, but she's a really neat lady. She actually died about 2 or 3 years ago at the age of 103, and I believe she was still active in the Italian Senate at that time or pretty close up until her death. She was a Jewish Italian neurologist, but unfortunately her lab work, at least lab work in a lab, had to come to a very abrupt halt because in 1938 Mussolini's race laws expelled Jews from public institutions, and she didn't let that stop her. She set up a lab in her bedroom. And she was interested in looking at the development of chicks, and so specifically the neural development. And so she would go to local farms and obtain chicken eggs, right, so that she could study the embryology here of those chicks. And I just think that is so cool that she set up that lab in her bedroom. I think in her biography, she had a really bad microscope, she said, but she was able to use sewing needles as scalpels to kind of dissect. So golly, man, you talk about someone who really was passionate about science to do these types of things. So yeah, she studied nerve fibers in chick embryos. And what she saw was whenever limbs were beginning to develop within these chick embryos, that the nerve fibers would begin to grow towards the budding limbs. And she hypothesized that those budding limbs were actually releasing something that was attracting those nerve fibers to it in order to innervate it. And she called that nerve growth factor, or NGF. It's a little figure there. The bottom one there is showing that growth. And so, yeah, she hypothesized that it was nerve growth factor that attracted those nerve fibers to innervate the limbs there. And so she wanted to continue on with this work. There was a lot of people at the time that didn't even believe nerve growth factor even existed, kind of told her she was crazy, and that wasn't really what was going on. But she continued her work in her bedroom, and if you read her biography, like, she even got kicked out of there and had to move to some underground lab. There was some really crazy stuff. Anyway, I don't have enough time for all of that, but what she was curious about is she knew in order to get people to understand this nerve growth factor actually existed, she needed to characterize it a little bit better. And so the very first basic question that she had was, is this growth factor a protein or a nucleic acid? And so in order to determine protein or nucleic acid, and this is very common, they did a lot of this whenever they were trying to characterize molecules, let's get rid of one of them and see if growth still occurs. And so she actually used an enzyme that would break down nucleic acid. What happened? Growth still occurred, but what was interesting is a whole lot of growth occurred. A lot of growth occurred. And so she said, all right, the growth factor must be protein. And she could have stopped right there, said, check, I figured that out, let me move on and characterize this further. But she was really interested in why so much additional growth occurred with the addition of this enzyme, all right? Well, then she started looking at what enzyme she actually used, and the enzyme that she used was snake venom. Snake venom was known to break down nucleic acid. And so she began to ask herself, I wonder if there is nerve growth factor in snake venom. And maybe that's what's causing this really large amount of growth there. And so she, instead of moving forward, she kind of took a few steps back and decided to look at that snake venom in a little bit more detail. And without going into all of this, all the details here, she did determine that the snake venom did contain nerve growth factor. You can see there's control up there on the top left. Top right is the crude snake venom. And then she took a protein fraction of the snake venom, which was shown here, and then the protein fraction of the nerve growth factor that she was originally using, which was actually from a sarcoma, mouse sarcoma there. But anyway, whenever she looked at this, she says, yeah, there's nerve growth factor in snake venom. And you're thinking, well, why is that a big deal? Well, up until this point, she had been struggling with trying to isolate enough nerve growth factor to study it. And just by chance that she used this snake venom to knock out the nucleic acid, she was able to see this extreme amount of growth. She said the snake venom did contain nerve growth factor, and it was 1,000 times more than they had ever been able to purify previously. So you want to talk about some good luck there, right? And so, yeah, they were able to move forward with their studies a lot quicker because they were more readily able to obtain this. But then they did switch to mouse salivary glands because they said it was easier, which I don't know how you get snake venom, but I can only imagine. And I would think that isolating that from mouse would be much easier. But they did switch to that. So let's think about this. Like I said, I could sit up here and tell stories all day long, all right, about scientific serendipity. But when we think about what life lessons can we learn from scientific serendipity, I hope that you don't take things like this away. When you're excited, you should run naked through public areas like Archimedes, all right? That's not what I'm trying to say you should do here. That is not a life lesson. Be bold, consume compounds that you generate in your lab. That's frowned upon too. Please don't do that. Entertainment is important. Try hallucinogenic drugs. That is not the lesson I'm trying to teach you today. Poor lab techniques could lead to you being knighted, like Sir Alexander Fleming, right? He had really bad techniques. Again, not what I'm trying to tell you guys. If you can't find some lab space, just set up a lab in your bedroom, all right? No, that's not what we're dealing with here. But what I do want to talk about is you're going to have changes in your plans, and you probably already have already, right? Really minor, really major. It can really span between those. But how we respond to our change in plans can actually bring about great discovery, just like these scientists. How they responded to this scientific serendipity there, right, really made a difference in why we're actually talking about them today. So just some little things to think about. What if Fleming threw away his contaminated plates without being curious about them? Right? We wouldn't have had penicillin when we did, maybe eventually, right, but not when we did. What if von Mering and Mikulski told a grad student to just go clean up the urine and go buy some fly tape, right? Clean up our mess, okay? Instead of exploring that and being curious about that. What if Montalcini did not pursue the huge increase in nerve growth factor, right? That was caused by the nerve growth factor. So have you ever had a change in plans? My guess is yes, all right? We all have. One of my favorite Yiddish proverbs is man plans and God laughs, right? Because our plans do change. And I am one of these very OCD people, and I am a planner, and I like to plan things out, and I like to know what's going to happen from point A to point B, and I'll make some lists about it and check things off a list, and that's just how I am wired. That is just in my DNA. In fact, when I was a kid, I had some very specific plans when I was a very young girl. My plans were that I was going to grow up and be the person that operated the pony rides at the fair. I was passionate about it. I told my mom that's what I wanted to do. She tried to support me in that as best as she could. I also said I was going to live in a mansion, something like this, right? I was going to have a maid, and I was going to have a cook. And whenever my mom asked how I was going to pay for all that on a pony ride operator's salary, I had an even bigger plan. I was going to marry Michael Jackson. And I told her that, and that was just my plan. That was what was going to happen, right? Well, none of these things happened. I don't have a maid, and I don't have a cook, all right? I didn't marry Michael, all right? And I don't do pony rides, even though I do like horses, but I don't operate pony rides there, all right? So yes, we can laugh when we talk about plans that we had as a child, right? But what happens whenever you have a change in plans in your life that are bigger than that and really, really tragic things can go down. And so I want to share just a few things about a change in my life plans that have occurred over the last 10 years with you. Whenever I finished grad school, my husband and I decided it was time to start a family. We were very naive about that whole process, thinking that when it's time to start a family, you get pregnant and you have a healthy baby, but that doesn't always happen. And so our first pregnancy resulted in a miscarriage. Our second pregnancy resulted in the stillbirth of our daughter. My third pregnancy was going along really, really well until my water broke 11 weeks early, and I gave birth to a 2.5-pound preemie. He was given a 50-50 chance of making it through that first night, and he did make it, so that was a really good sign. He went on to be in the NICU for 6 weeks, and during that time developed a lot of health complications, which included a grade 3 intraventricular brain hemorrhage. They told us that he was probably going to have cerebral palsy and other types of mental impairment because of that particular brain bleed. He had a lot of lung issues from being on a ventilator for so long. But I am happy to tell you that that little preemie is now a 7-year-old second grader who is extremely bright, has no medical complications, just some mild asthma as a result of being on that ventilator for so long. And we feel so blessed by that. But then I had even more changes in plans. In 2010, I went in for a routine gallbladder removal. And upon a checkup for that, I was actually, they discovered I had an enlarged lymph node. And it turned out I was diagnosed a week later with metastatic thyroid cancer. I went in and I had my thyroid removed. I had all of my lymph nodes removed on the right side of my neck. And then following a radioactive ablation procedure, in November, I will be a 5-year cancer survivor. So you can clap. Hey, I'm proud about that. I'm proud about that. And then I will go on to tell you that in addition to my healthy 7-year-old that had a rough start in life, I do have an almost 2-year-old that was born full term. Actually had to be induced with her. God has a sense of humor, all right? And she was born perfectly healthy, 8 pounds, 6 ounce, big fat baby girl, and she is doing great. So I tell you about my story because I don't want to bring us down, right? Don't worry, we're going to go right back up again. But I tell you about my story because I want you to understand that you will have in your life a change in plans. Right now, you may have had a change in plans. You may not have made the grade that you wanted to on a test. I deal with students all the time who med school is no longer a reality, or maybe being a biology major just isn't as fun as they thought it would be. And so we've got to figure out what they want to do, what God has called them to do. But it's all about figuring out through that process, discovering something. And what is God trying to tell you through that process? And through my process that I've been through, I can tell you right now that it has been one of great discovery, because this is what I have discovered. Life is messy, all right? Life is just messy. But God loves us. He walks with us through all that. He carries us. He cries with us. And then He rejoices with us when we come out on the other side of that, right? And so in thinking about these life lessons and what we can learn about that, I want to kind of compare it to what some of our scientists did whenever they had this change in plans. So how can your change in plans be a life discovery? Well, using the phrase of Louis Pasteur, have a prepared mind. And what does that mean? How can you have a prepared mind? Know that things are going to go awry. All right, know that life is messy. You will have a change in plans. How do you prepare yourself for that? Well, you surround yourself with family and friends that can support you through that. You invest in your relationship with God because you know that He's going to be there whenever you're walking through something like that. All right, so having a prepared mind, like our scientists did, is really important. Be sagacious. That particular term means having or showing keen discernment, sound judgment, and farsightedness. So how can we do that? We can do that through prayer, asking, what is God telling me through this process, all right? Thinking, prayer and even meditation, you know, how can I put a positive spin on this, right? How can I turn this into something good? And then also collaborations. You'll notice that all of these scientists we're talking about, there might have just been 1 or 2 names that I mentioned, but there was a lot of people backing them up behind that, right? Collaborations are so important. And so when you're walking through some sort of change in plans, no matter how small it may seem, right? Collaborating with your friends and your family is really important. And I'm here to tell you, you guys are in an amazing place for that, all right? Because I know that I would not have come to my life discovery had I not had my time here at TLU, because I still, through that whole process, was talking to all of my friends. I was just telling Dr. Squires earlier, like my potluck roommate when I came to TLU and I are still very good friends. And so having that network of friends around you here, those relationships that I developed with my friends, but also being more grounded in my faith that I got here at TLU were so important to dealing with these types of changes and plans that I've had. So be sagacious. Respond to the change. It's okay to get mad about something, all right? You can get mad, you can get sad, that's okay, that's perfectly human. It's a perfectly human response when you have a change in plans, all right? You thought you made an A on the test, and it's a C. That's a pretty big change in plans, all right? You can get upset about it, that's fine, all right? But don't stay there for a long time, all right? Get back up. Get back up and start walking again. And knowing that in order to get from A to B, right, when you get back up, it may not be a real quick walk, right? It may be a journey, right? This life discovery process here, but get back up and start walking again, all right? Very important. And then lastly, share your discovery. And I'm going back to where we started here with Archimedes, right? Once you have your life discovery, right, share that with others. That's what our scientists did, right? They shared it with the scientific community. Your life discovery that you make, share it with your friends, right? Because you can be an encouragement to others. But through that whole process, please wear your clothes. All right? Don't go running naked through the public baths and everything. That's all I have for you today on as far as scientific serendipity. But I do want to put up a slide, and I would be happy to talk to anyone afterwards about graduate programs that we have in the biology department at Baylor. We do offer a PhD program in biology. We have both an MA and an MS program. Our MA program is actually a 1 calendar year program, so 3 semesters. It's a summer, a fall, and a spring. And that's a health concentration. And so the people that typically go into our MA program are those that are taking kind of a gap year before med school, or maybe they want to get their GPA up a little bit more. That's what our MA program is. It's a non-thesis program. Our MS program is a thesis program there. And I would be happy to answer any questions that you guys have about that, or anything that you want to talk about. Thank you very much.
Students at TLU engage in high-impact educational experiences that include civic engagement, aesthetic expression, critical thinking, and a focus on intercultural knowledge in a community that welcomes the interplay of faith and reason.